In section 12.6, we're going to talk about binomial distributions. So what are you going to learn? You're going to learn how to construct and interpret probability and binomial distributions. So we'll start with probability distributions. A random variable is a variable whose value is determined by the outcomes of a probability experiment. For example, if you would roll a six-sided die, you can define a random variable x that represents the number showing on the die. So the possible values of x would be 1 through 6. For every random variable, a probability distribution can be defined. So here's your core concept. Probability distributions. A probability distribution is a function that gives the probability of each possible value of a random variable. The sum of all of the probabilities in a probability distribution must equal 1. So if we look here, probability distribution for rolling a six-sided die. X could be 1, 2, 3, 4, 5, or 6. And each of those probabilities of x would be represented by 1/6, since they're all equal. And if you added them all together, it would equal 1. We're distributing the probability to each of these events. So in example 1, we're going to let x be a random variable that represents the sum when two six-sided dice are rolled. Make a table and a histogram showing the probability distribution of x. We just want to see how it can be distributed among all of the possible outcomes. So let's start with our table. Now on page 670, on example 3, it showed all of the possible sum totals. Now the lowest sum we can get for two die is 2, the highest is 12. Now if you actually looked at the table and looked at all of them, there's only one way to get a 2, 2 ways to get a 3, 3 ways to get a 4, and so on. And you would have to make a table of some sort to figure that out. So we know that the total possible outcomes of everything are 36. There's going to be 6 times 6, 36 total ways. So this would be 1/36. This would be 1/18, which is 2/36. This would be 3/36, which would give us 1/12, 1/9, and so on. That's it. So we divide all of our outcomes, all of these, by 36 to get P of x, the probability of x. This is how you show probability distribution. So the next step is drawing a histogram, which is a bar graph where the bars, there's no spaces in them. So the probability of, here's the sum, and this is the probability. So we can go from, this is actually increasing by 1/36, 1/18, and so on. So you can label this however you want, but since it's fractions, we can have our bars go up by fractions. But it would look like this. So now we're going to use the probability distribution in example 1 to answer each question. So if you look at A, what is the most likely sum when rolling a two-sided die? Well, we use our table. As you can see, the probability is greatest when the sum is 7. B, what is the probability that the sum of the two dice is at least 10? So we want the probability of x is greater than or equal to 10. So that means the probability could be x could be 10 plus the probability of x could be 11 plus the probability that x could be 12. That would give us 3/36 if we're using our chart, plus 2/36 plus 1/36. That gives us 6/36, which is 1/6, which is approximately 16.7%. Binomial distributions. One type of probability distribution is a binomial distribution. A binomial distribution shows the probabilities of the outcomes of a binomial experiment. So, a binomial experiment meets the following conditions. There are n independent trials. Each trial has only two possible outcomes, success and failure. The probability of a success is the same for each trial. The probability is denoted by P. So if P is the success, the probability of failure would be 1 minus P. So for a binomial experiment, the probability of exactly K successes in N trials is the following. The probability of K successes is N choose K, P to the K power multiplied by 1 minus P to the N minus K power. It looks like a very confusing formula, but we're just going to plug in values. According to a survey, about 33% of people ages 16 or older in the U.S. own an electronic book reading device, or an e-reader. You ask 6 randomly chosen people ages 16 or older whether they own an e-reader. Draw a histogram of the binomial distribution for your survey. So, this is where we're going to start. We know that the probability that a randomly selected person has an e-reader, it says right here, is 33%. Because you survey 6 people, N, if we look back at our formula, our key idea, N is what? N is the number of trials. So N would be 6. That's how many times it's happening. So what you're going to start doing is this. P, and now we want to know if K is 0. So we can have choices, either all 6 people or no one has an e-reader. So this would be 6 people, choose 0. Now 33% is our P. And why is that? Well, we know that P is the success. That's what we want. We want to see who owns our e-reader. So 33% would be our success. Now, to the 0 power, multiply by 0.67, because that's 1 minus our success, to the 6th power, because that's 6 minus 0, and this would give us approximately 9%. And we would continue that. What's the probability of 1, 2 people to have a reader, 3, 4, 5, and 6? And now we want to draw a histogram. So the histogram is going to show the binomial distribution for our survey. And there it is. There's our binomial distribution. And as you can see, 0 people, we can count or make our increments by 1/10 or 10 hundredths. And so we fill these in, and there's our binomial distribution. So what does it all mean? You're probably like, I don't know what any of that means. Well, we're going to use the binomial distribution in example 3 to answer each question. So what is the most likely outcome? Well, the most likely outcome, the probability, as you can see is over 30%, would be 2 people of the 6 surveyed own an e-reader. B, what is the probability that at most 2 people have an e-reader? So we want the probability of people who have an e-reader, 2 people have an e-reader, or less. So we would add the probability of no people, plus the probability of 1 person, plus the probability of 2 people. So that would be approximately 0.09 plus 0.267 plus 0.329. That would give us approximately 68.6%. And the vocab from this chapter would be these 4 terms.